In this video, we are solving two linear systems using the inverse. For example, this is the first linear system and here the second linear system. Now let's read the question first. This is the example. Let the matrix A here equal -1, 1, 2, -1. So this matrix here A, which is size 2 by 2. So here the dimension, order, or the size, it's equal to 2 by 2. Find the inverse of A. So we have to find the inverse of A. Question number 2. Using part 1, which is this one, solve two linear system AX equal B and AX equal C, where B equal this vector here 1, 1, which is 2 by 1, and here this vector which is 2 by 1, the same thing. So we have to find this vector x. It's very simple, as we have find A inverse from here from part 1, we will use it to multiply both sides of the linear system here from the left. So we have to multiply here A inverse and here A inverse. We will get the answer x equal A inverse multiplied by B. I will illustrate all this in a nice way when I answer number 2. Now, to understand the concept of the inverse of a matrix, we have to know that if you have A inverse exist, then you have to know A multiplied by A inverse equal A inverse multiplied by A equal identity. Here it's like multiply a number by its reciprocal. It's like multiply 3 by 1 over 3, which is equal to 1 in the same sense. But in matrices, here A multiplied by A inverse, you should always get identity matrix. Here, there's a matrix, not a number. Now, let's understand how we are solving a linear system using the inverse, as I have said here. So if you have AX equal B, so here's the example for how to use A inverse if A inverse exists. So if A inverse exists, we have to multiply both sides from the left of this equation. So A inverse multiplied by this and A inverse multiplied by B. So you will get here A inverse multiplied by A multiplied by X, and here you will get A inverse multiplied by B. So this here exactly the same as here, but we have multiply A inverse here and here. So you will get this. And you know, if you have A inverse multiplied by A, you will get here identity. So from here to here, you put identity. And here it remained the same. Here it remained the same. Any matrix multiplied by identity, it will remain the same, so it will not affect anything. So you will get here x. So here, if you symbol this side, you will get x. So here you will get x equal A inverse multiplied by B. So here exactly we will do the same as here. So you have to multiply by A inverse. So the answer, it will be x equal A inverse multiplied by B, and here it will be x equal A inverse multiplied by C. Now let's review how to find the inverse of a matrix and dive in to understand each step. The step to find A inverse, first we have to write it on augmented form. So here we have to write, if you have A, you have to write it like this with augmented form. Then if you can transform this A to identity by RREF, which means that you use elementary row operation. There are three types of row operation, which are row switching, row addition, and row multiplication. Of course, the operation that you apply to the left side, you have to apply it for the right side as well. So if you can transform A to identity, then this side it will be here A inverse. And the same thing, if you want to back again, if you put here A inverse and here identity, Then if you transform A inverse to identity, then here you will get back to A. Note that if you can transform A by reduced row echelon form, which is RREF, to identity, then A inverse exists. If you cannot transform A to identity, like here I put not equal, then A inverse does not exist. For example, if you cannot transform it to identity, for example, if you apply RREF and you have a 0 row, then you cannot transform it to identity, then A inverse does not exist. And the same thing, if they told you A inverse exists, then you have to know that you can transform A to identity. Here, if you have A inverse does not exist, then you have to know that A cannot transform to identity. That's it here. So in our example, we will solve it with method 1, then we will use method 2 as well to find A inverse. The second method, you can find A inverse by finding the determinant and the adjoint, or they called it adjugate, of A. And you can see here the determinant of A in the denominator. So here, if this equal to 0, you have to know A inverse does not exist. For example, here, if this determinant of A equals 0, you have to know A inverse does not exist. And the same thing here, if you have the determinant of A not equal to 0, then you have to know A inverse exists. The opposite way, if they told you A inverse exists, then you have to know that the determinant of A not equal 0. If they told you A inverse does not exist, then you have to know the determinant of A equal to 0. In case, like in our question, if you have 2 by 2 matrix, then we have simple formula to find it, which is exactly the same as here. So here, the determinant of A, so let A equal to this one. The determinant, of course, A multiplied by D, which is here, minus B multiplied by C, which is here. So here, it's equal to this one. The adjugate, if you can apply the adjugate of A, then you will find out at the end to be like this. So you have to swap this, then you have to put here minus and here minus. But you can save it in your mind to find it more easier. So here, the two methods. Now let's explain more about linear system. If you have AX equal B, if you use Gaussian elimination or Gauss-Jordan elimination, like if you put this one like this, and here B, an augmented matrix, and if you apply RREF, if you get like this, then you have to say a unique solution. If you get like this, you have to say infinitely many solution. If you get like this, no solution. No solution if you have here this 0 row and here number. Infinitely many solution if you have a 0 row and here 0. And you can see in this, you cannot transform A to identity because here you have here 0 row. So that's why here A inverse does not exist, and here A inverse does not exist because you cannot transform this side to identity. But here in a unique solution, if you apply RREF to this side, you will get like this. Therefore, A inverse exists. So this is behind what we have done here. So if you can transform A to identity, then A inverse exists like this here. You will get a unique solution. So this is very important to understand the concept and to know more than one method and combine them together to understand the general concept. Now let's solve the question. So here you can see if A inverse exists, then AX has a unique solution, which is exactly as we have done here. Now let's go down to solve the question. Now let's solve number 1. We have to put A and here identity matrix with the same size as A, which is here 2 by 2. So we wrote A here as an augmented matrix with identity with size 2 by 2. We want to do RREF to the left side. The left side, I mean that the matrix before this line, which is here, which is the matrix of A, and the operation that we do to the left side, we have to apply it to the right side as well. So here, this is the matrix here, -1, 1, 2, -1, -1, 1, 2, -1, and here the line of augmented matrix, then here 1, 0, 0, 1. Now here, if you apply RREF to the left side, so here we have to transform this side to identity. So here 1, 0, 0, 1. So just like this. So we have to multiply this row by -1. This row to remain the same, so I will speed it up to write this row. Here it will be 1, because here multiply by -1 for the whole row. Here it will be -1, -1, 0. Here, this one, they called it a leading one or a pivot. So now here we have to make this one 0. So 2 minus 2. So here we have to multiply this row by 2 and we have to subtract. So 2 minus 2, here it will be 0. So row 2 minus 2 row 1 in row 2. This row it remains the same, so I will speed it up. Now 2 minus 2 multiplied by 1, so here 2 minus 2 multiplied by row 1, which is here 1, so 2 minus, here it will be 2, so 2 minus 2 equal 0. So here I have to write 0. -1, -1 minus 2 multiplied by -1, so -1 minus with negative, it will be positive. 2 multiplied by 1, which is 2, and the answer it will be 1, because -1 plus 2 equal 1. So here I have to write 1. 0 minus 2 multiplied by -1. 0 minus 2 multiplied by -1. So it will be 0 minus with negative, it will be positive. 2 multiplied by 1, which is 2. So the answer it will be 2. So here I have to write 2. 1 minus 2 multiplied by 0, it will be 1. So here we have a leading one, and here a leading one. So this one we have to make it 0. So we have to say -1 plus 1, it will give you 0. So we have to add this row with this row. So row 1 plus row 2 in row 1. So this row remained the same, so I'll speed it up to write this row. Now row 1 plus row 2. So 1 plus 0, which is 1. -1 plus 1, which is 0. -1 plus 2, which is 1, 0 plus 1, which is 1, and this one equal to here identity with size 2 because 2 by 2, and here we get A inverse. I'll change the color again. So here this is A, and here identity. Then we can transform here. You can see we can transform A to here identity. Therefore here A inverse. Therefore, this is the symbol of therefore. A inverse exists, and A inverse equal to 1 1 2 1 1 1 2 1. So that's it here. Here we have found A inverse by this method. So as we go up, we have found A inverse by using this method. Now we will find the A inverse by this method. Let's go down again. We have solved it by this method. Now another way to solve 1. Here we have at the beginning A equal, which is this one, negative 1, 1, 2, negative 1, negative 1, 1, 2, negative 1. Here this A. And as we did before, if you have A equal A, B, C, D, then if you want to find A inverse, then you have to write it like this. A multiplied by D, A multiplied by D, minus B multiplied by C, which is the determinant. And here this matrix, it will swapping these two. So here it will be D, and here A. I will close this, and here it will be minus B, and here minus C. So here A inverse equal to 1 over negative 1 multiplied by negative 1 minus negative 1 multiplied by negative 1, because here as here we multiply this one by this one. So here this one minus, I put here minus, and I will make it larger. B multiplied by C, B multiplied by C. So here I have to multiply this by this. 1 multiplied by 2. And here this matrix, it will be swapping these two. So I have to swap these two. Here negative 1, negative 1. If you swap it, it will be the same negative 1. Here negative 1. And I will close this bracket. And here I will put negative B, negative C as here. So here I have to put negative to this element, negative to this element as here. So negative of 1, and here negative of 2. And this answer of this one, and as you can see, negative 1 multiplied by negative 1, which is 1, minus 1 multiplied by 2, which is 2, and the same matrix here, negative 1, negative 1, negative 2, -1, and the answer of this one, 1 minus 2, which is -1, 1 over -1, -1, -1, -2, -1, and here the answer of this one, it will be negative. I wrote everything step by step, and if you insert the negative, every element here, it will change the sign. So here it will be 1, negative with negatives here, it will be here 1, and here 2, and here 1. Of course, you can simplify from here to here if you are very fast to write this. So you can simplify, of course, here to immediately to here if you can handle this. And you can see our answer exactly the same as this method. Of course, they have to be the same answer. So here I will write the same as here. Therefore, A inverse exists and A inverse equal 1, 1, 2, 1. That's it. We have solved it in two ways. So now we have solved number 1 by 2 method. Now let's solve number 2. Now we will solve the two linear system AX equal B and AX equal C, and here you will see how the beneficial of the inverse of a matrix to solve these two linear systems. And you can see, of course, here this A 2 by 2, here this A 2 by 2, and here B 2 by 1, and the same thing here 2 by 1, and here 2 by 2, and of course here this X, it has to be 2 by 1 because this side, it has to match this side, and the answer, it will be 2 1, here 2 1. So it's very important to understand this, but you can solve it without put these things. So now we have to solve this AX equal B and here AX equal to C. So the first we will solve AX equal B, the system AX equal B, then we will solve the linear system AX equal C. Now let's go down to solve number 2. Now we want to solve number 2 for linear system AX equal B. As we have A inverse, since, I will write it here, since AX, I will write this again, equal B, then because we have already known A inverse exists, we have to multiply A inverse both sides from the left, as I have illustrated in here. As I illustrated in here, so I will write exactly the same as here. So multiply from the left by A inverse. So here I have multiply A inverse, and here A inverse, and here I have multiply A inverse, and here is the A inverse. Then here you know this, it will be identity. So I write here identity with size 2 because it's 2 by 2. And here X A inverse multiply by B. Then identity multiplied by X, it will be X equal A inverse multiplied by B. A inverse multiplied by B. So here the answer. So here I have to write x equal A inverse multiplied by B. A inverse, which is here, or if you want to take it from here, the same thing. 1, 1, 2, 1 multiply by B. Where is B? 1, 1, 1, 1. 1 multiplied by 1, which is 1, plus 1 multiplied by 1, which is 1. So 1 plus 1 equal 2. So here I have to write 2. 2 multiplied by 1, which is 2, plus 1 multiplied by 1, which is 1. 2 plus 1, which is 3. So here I have to write 3. So this is the solution for the linear system AX equal B. So therefore, I'll put like this, therefore, the linear system AX equal B has a unique solution which is x equal, and we know x look like this, x1, x2 equal 2, 3. That's it here. Now we want to solve the linear system AX equal C, as here, AX equal C. For linear system AX equal C. So here we have solved this AX equal B. Now we want to solve AX equal to C. I will write exactly as this, but instead of B, I will change it to C. So here I will write since AX equal C, which is this one, then we have to multiply from the left by A inverse and here by A inverse. So it will be A inverse multiplied by A x equal, and here A inverse C. And you have to know here this equal to identity, as we explained it before, as here if you have A inverse multiplied by A equal identity. So here it will be identity. I'll put as here. So here it will be identity with size 2 by 2. As we know, A is 2 by 2, so therefore here 2 multiplied by X equal A inverse multiplied by C. And we know any matrix multiplied by identity, it will remain the same. So here it will be X, A inverse multiplied by C. So this is the answer. So here we have to write X equal A inverse multiplied by C. And we know A inverse, which is the same as here, or like here, A inverse. So 1, 1, 2, 1, 1, 1, 2, 1. Now I have to write C. Let's go up. C, 1, 2. 1, 2. Now let's multiply these two matrices. And you have to know, since here 2 by 2 and here 2 by 1, because 2 by 1 because it has 2 row and 1 column, and here it has 2 row and 2 column. So here this matrix, it has to be size 2, 1, because this equal to this. Therefore, the result matrix of multiply these two matrices, it has to be 2, 1. So here 2, 1. So it has 2 row and 1 column. Now 1 multiplied by 1, which is 1, plus 1 multiplied by 2, which is 2. 1 plus 2 equal 3. So here I have to write 3. 2 multiplied by 1, which is 2, plus 1 multiplied by 2, which is 2. 2 plus 2 equal 4. So here I have to write 4. That's it here. Therefore, the linear, I will write exactly the same as here. But of course here, the solution is not like this. The linear system AX equal C has a unique solution, which is here X equal X1, X2 equal 3, 4. That's it. So we have solved number 2. And you can see here, we have found the solution here by multiply the inverse by C. Just multiply A inverse by C, we get the solution. Here, A inverse multiplied by B, we get the solution. So it's very beneficial to find A inverse, especially if you have a big matrices, like what we will see in the next video. Now let's go up. So we have found the inverse of A, then we have used it to find the solution of the two linear system AX equal B and AX equal C. That's it. In the future, we will do more videos about the inverse of a matrix. Also, we will see a different way to represent the question about solving two linear system using the inverse. Feel free to comment below if you have any question or suggestion about this video. See you in the next video.